So I guess the first question, because we weren't sure what the level of experience was going to be here, so how many people here have been coding in Ruby and Rails for more than a year? And how many people here have used either Resque or Sidekiq? Okay, so we got one. Okay, so I hope this isn't too high level for you, but I think if you're going to be programming in Rails, this is something that you're going to need to know if you want to build production applications. We use them pretty heavily in our application. So I guess first I'll ask if anyone, why would you use background processing, whether it's Rails or any other framework, .NET, Python? Does anyone have any ideas?
Take some of the load off of your web workers,
Huh?
like background jobs such as sending out emails or processing some other type of transaction in the background.
Yep.
You're going to do anything that's really slow.
Anything that's slow? Yep.
Yeah, when you're running background processing, this is more of a question. When you're running background processing, it still takes up space and memory, but it just frees up the terminal. I don't understand what the advantage is to having your app in background processing.
All right, so we'll get into that. All right, so those are great answers. So separating responsibilities is big. Your web is responsible for just taking in requests and then getting data and giving it back to the users, right? You don't want to necessarily be doing some very intense processing that are slow on the web processes, because their responsibility is just to do web requests and get data and send it back. Scaling and reliability. So when you have an application, the last thing you want to do is have something fail and throw an exception at the user. So a lot of times you can offload things to a background process, especially if they're going to do things like go off to an API to another site. What if the site's down and you can't reach that API? What are you going to do to the user? So it's nice to be able to tell the user they can feel good, like things are working, and then in the background process go and try to do those things, right? And the last thing is user experience, right? I think the most important thing in an application is to hurry up and get the job done. Like, they make a request, they press a button, you should immediately come back and say you're done. And if it's still taking 5-10 minutes to process their work, that's fine, but they don't have to sit there and wait. And so a lot of application developers or applications, they do too much processing in that same thread, that web thread. You click the button and there's too much going on, right? And that makes the experience feel really slow. And so user experience is actually an incredibly important reason to use background processing. Some of the common use cases that I see out there are emails, reports, say you want to do daily or nightly or hourly reports. Heavy queries is anything statistical in nature. Webhooks is one that's actually pretty prominent now, where, for example, you have an endpoint that every time someone checks into GitHub or someone does something in Slack, you want to be notified, right? It's nice to put that in a background process and just, because you never know what the load is going to be. You can get a million requests in 2 minutes, or you can get none in the next 5 hours. So to be able to put that in a process, a worker queue, to sort of balance and load that and deal with it when you can, that's an incredibly powerful thing. The other one is integrations. If you're ever going to go out and call other people to do some work, it's nice to put that in a background process again, because if it fails, you can do something about it. Versus if it's just something you do one time, what do you do if it fails? You send an email to yourself or you log it, and then you have to kind of go through there and figure out why it failed and run it again. And then anything long running, if it takes more than a few milliseconds, then you should probably put that in a background process. Some of the things we use background processes for, again, email is the first thing you should probably put in the background process. We do a lot of reporting. We do application notifications. So one of the things we do is whenever we hit certain milestones in the application, it'll, some background processes are just listening for events to happen, and it'll actually shoot emails to Slack. If you guys ever use Slack, it's like a group chat application, and so we spend all our time on Slack and we get notified there all the time. The next one is something, I think it's kind of unique. It's anomaly detection. And what this is basically, we're constantly monitoring, trends in our application. And if we see something that's off, we're constantly running these jobs and saying, hey, did registrations just fall by, more than 30%, during this time? We shouldn't be seeing ever, traffic or registration slow down. So if it slowed down, there's a possibility that we committed some code that broke something, because we push out to production, 10, 15 times a day as a team, and, mistakes happen, and even through code reviews and testing, you're bound to make a mistake, and if we see something kind of go off the trend, we'll immediately notify ourselves with this anomaly detection that's running in the background process constantly, and then it'll notify us. The other thing that's unique to us is something called device syncs. So a little bit about our application, our product. We actually integrate with all the major fitness trackers. And we sell to businesses who want to get their employees engaged, get them active. And whether it's FuelBand or Fitbit or Jawbone, these things are constantly syncing. Here you did 100 steps, you did 1,000 steps. They're constantly syncing. We have to be able to get that data and process it. And so all those device syncs, we get a million of these a day. We have to handle them somewhere. We don't want to do it through a web request, so we'll put them in a job. And then that'll sort of take care of, if there's too many in the queue, it'll throttle them. It'll just kind of back up. And if there's not a lot, then it's fine. So it's a way for us to sort of manage the load without, failing because too many things are hitting the web, the web process. And then what is unique to us is challenge scoring. I'll actually show you guys our actual live Sidekiq and Resque background processes. So, how does it work? How do you, integrate in your application? It's actually really simple. It's no different than calling like a class method. Not an instance method, but a class method like, job.performSync. So I'll show you that as well. But it's really simple to get integrated. It can be invoked directly in your code, or you can, we do a lot of, scheduled tasks where we'll just run things hourly every 10 minutes, and they'll invoke the jobs, the background process jobs. The other thing is they're run as a separate process. So you have your, if you guys are familiar with Heroku gives you web processes, and then you can get some worker processes. If you are running your own, instance of Linux or whatever, you can say, hey, I want to dedicate X amount of processes and X amount of, background processes, X amount of web processes. So those run as a separate web process, so that you can scale and you can say, hey, I need more web processes, I'm going to add more web processes, or I need more background processes to handle that load. But if they're all together, you don't have really any idea whether it's the web or the background work that's causing yourself to not scale.
Quick question.
Yeah.
When you say web processes, do you mean like just requests from the user side?
Yeah. Yeah. When I say web processes, I'm talking about just someone hitting your website. Yeah. And when I say background or worker process, that means these jobs, these background processes that are on these jobs. The other thing is this idea of reliability. Again, these queue systems or these background processes have things like retries. So if it fails for whatever reason, the API may be down or someone committed an error, it'll fail, but then it'll retry. And they have really cool algorithms to say, hey, I'm going to fail, I'm going to retry in 2 seconds. And if that fails, I'm going to try in 4 seconds. If that fails, I'm going to try in 8 seconds. And it'll keep going on that sort of algorithm until it gets about 21 days. And at that point, it says, okay, this is probably dead, so I'm going to put it in the dead pool. And then you have a place to go look and say, how many things are failing currently, and how many things have never succeeded and are now in the dead pool. So you can still pull them out of the dead pool and bring them back to life. So this is good, like if it's transactional, like you have to get this thing done. You want to have that reliability where if it fails, it's going to try again, right? If it's a web request, if it fails, it's going to go in a log or an exception, and you don't know whether it succeeded or not. It's not as reliable. Queues. So another cool feature is queues. The idea that you can say, hey, I don't just want a bunch of background processing, but I want to be able to say that these are critical functions, right? So I want to give priority to them, whatever that means. And these are hand emails, whatever. They're notifications. I don't care if they get them 2 hours later. So you can actually put a priority on your process, say, and then label your jobs and say, these transactional jobs, I want them to have the highest priority. So I want them to run 20 times as often as my email senders, so that they're running immediately, right? And you never back up in those. But if they're emails, whatever. If it takes an hour, 2 hours to send out, no problem. And the other thing about background processes is they have to store this data somewhere, right? Because if you recycle your web processes, if they crash, they go down, the job has to be somewhere, right? On disk somewhere. And so usually they'll use relational databases, like this is the default out of Rails, it's called delayed jobs. But the better approach, the more robust approach is to use Resque, which is a key value database that most of these background processes use. So there's a lot of options with background processing tools. Delayed jobs, like I said, that's kind of like the default. If you just want to get something working like emails, you can use delayed jobs. I've never used it. I don't really believe in the idea of putting your background process in your database because your database doesn't need the extra load. So the ones that we've used is Resque and Sidekiq. But there's a link here, and there's actually a ton. There's another 10 or 15 that are pretty popular. But I want to say that Resque is kind of the one everyone gravitates to when they need something. And then if their application is successful, then they'll graduate up to Sidekiq, which is more powerful, but more complex. Right? You can get in trouble with Sidekiq. And I'll kind of demonstrate both of these. A couple other considerations when you're sort of choosing a background process tool is whether they're threaded or process-based, right? So Resque is process-based. That means for every job you want to execute or perform, you need an entire process to do it. Whereas Sidekiq is threaded. So you might have one process, but say, hey, I want to split this process into 20 threads. And if you guys are familiar with threads and processes, they're just units of work, right? So processes is the larger unit of work. In a thread, you can have 5, 10, 100, 1,000 threads within a process. It's all dependent on how much sort of memory and capacity you have in the CPU or the process itself, and sort of the size of the complexity of the jobs themselves. So you have to kind of tune this when you're doing threaded, and that's kind of why I say when you're doing Sidekiq, you can get yourself into some trouble because it's threaded. So you have to do more configuration and more tuning. Versus Resque, it's like you get the whole process. There's almost no way you can screw it up, quite honestly. Again, we talked about storage type, whether it's Redis or a relational database like Postgres, and then the complexity. So with that, I'm going to go ahead and just kind of run through, and I can throw some on GitHub if you guys want to play with this, because it's kind of cool to play with the different parameters. This is a very, very base Rails app. In fact, there's like no controllers, there's no views, there's no nothing, there's no models. It's actually just configuration on how to configure Sidekiq and how to configure Resque. And I'm going to be able to cover that because it's pretty easy. Like you guys can look at the instructions and it'll take you guys probably an hour, maybe 2 hours. If you're really smart, it might take you 15 minutes to set this thing up for the first time and get it up and running. So that's trivial. So what I'm going to show you guys is more like how they work in real applications, some of the key differences. So what I've set up here is, can you guys all see the screen? Do I need to make it bigger? You're good? So the things here in jobs, and this is not a convention, this is just something I kind of chose to kind of show the difference. The two jobs here in the jobs directory are rescue jobs, right? So this guy and that guy are rescue jobs. And the two jobs in the queues are Sidekiq jobs. And again, these are different background processing tools. They're open source. And so these are the two Sidekiq jobs. So what am I doing? I'm simulating something happening. Like you call this job, and I'm simulating that this is going to take about a second to do its work. There's a sleep call, it's sleep 1 second. And here I'm simulating that it's going to take about 5 seconds. So a lot of our jobs take 1 second, some of them take 5, some of our jobs take 12 minutes, right? So you'll have this different variability in your jobs depending on how much complexity and how much work you're doing. And then the queue, same thing. The email one is 1 second, and the report one is 5 seconds. Okay. And then all I've done is I created a rake task just to, actually before I do that, I'm just going to go ahead and call these directly from the console. So I'm just going to go into the Rails console, and I'll make it a little bigger actually, you guys can see. And I'm going to call, say for example, that guy. Okay. So I'm just going to say email verification.perform. And this guy requires one parameter, which is the ID, and I'm just going to pass anything there. Oh, sorry. I forget the syntax. Perform async. So that gave me this GUID. This is the unique number for that job. And I will show you, the cool thing about both these applications is that they come with a web server, or like a web interface. So you don't have to like always be in the console. You get a full-on web interface for both Sidekiq and Resque. So this is Resque, and this is Sidekiq. So I just went ahead and triggered this job called email verification. So I'm going to do it again, and you'll see it kind of come through here. So do that, come here, and you'll see it might be going too fast. So it's so fast that you're not even seeing it. So let me do the other one.
How long is this for?
1 second. So let me do the weekly report. I want to say it was called weekly report. Here it goes. So you see it busy there? It's working on that guy, weekly report right there. And I passed the argument number 3, and it started listening to me. Right, here's the unique ID, and then it's done. It goes in process, complete. Right? So what I want to demonstrate is what happens when you push a lot of jobs to Resque, what happens when you push a lot of jobs to Sidekiq, and why the differences in their architectures matter, and how you can scale them. So what I did is I created a couple rate tasks. It's just a command line thing so that I can go ahead and kick off as many of the email jobs as I want, or as many of the report jobs as I want, without having to hit enter and type it in as many times as much time. So here's this again. This is just, don't worry about this. This is basically saying I want to run the email invitation 50 times, and I want to run it in a rescue R, right? So I'm going to go ahead and do that.
John, keep going up here.
Oh, yeah, sorry. Sorry, I changed this to emails. So that now it's in rescue, right? So it's done. So if I'm a user, this job is done. But now rescue started going off. So 46, 45, 44, 43, right? You just see that kind of going down. It's taking its time. Your web process is serving users, but your background process is doing work. That's not affecting users. Take as long as it needs to take. So I'll go ahead and do the same thing for Sidekiq. And ask for me, just again, it's just a helper to symbol, to kick off the Sidekiq job. So again, 44 are in queue. In queue is the word, but they're in the queue. And there's one process that's busy, or one thread that's busy in Sidekiq. And it's just doing them one at a time. Number 16, number 17, number 18, number 19, number 20, right? So, cool, right? So, kind of talk a little bit about what happened to us at Matchup. We started using background processes for emails and simple things like that. And we got in trouble because all of a sudden, people started using Matchup, and these fitness trackers are syncing constantly every 5, 10, 15 minutes. And we would just get to a point where we'd have 30,000, 40,000 jobs in queue. And we're like, what? And so all we can do is add more processes, more background processes. We got to the point where we were paying like $1,200 for background processes on Heroku. And we realized that's not sustainable, And so that's why we made the switch to Sidekiq, to say, hey, we need to be able to take one process that we're paying for. It costs $33 on Heroku, it costs $5 on DigitalOcean, but it's not nothing. And we want to be able to process 5, 10, 50 jobs per process, because these guys don't take a lot of memory and a lot of CPU. They just take time. So I'm going to go ahead and show you the difference between the two. Say you're running 1,000 jobs, right? So I'm going to do the 1,000 here for Resque. But before I do that, I'm going to do one thing. I'm going to come in here into configuration. So there's a configuration for Sidekiq that lets you say, hey, I want this to be concurrent. And I don't want just one concurrent thread. Let's start with 30 concurrent threads, right? So for that same one process, I'm going to have 30 threads that are doing work simultaneously. Okay? So let's kick off Rescue. Get 1,000 jobs in there for, well, I guess emails is fine. So that's working, right? And it's logging away. Now I'm going to do, actually before I do that, one thing with queues you have to remember is you have to actually, anytime you change a queue, you have to shut down your Rails server. Otherwise, it won't pick up the new code. So I just restarted the web server. This guy is an initializer, right? So it's just done one time at the beginning, and then it doesn't do it again. Okay. So make this bigger again. Sorry, guys. So I'm going to change it to Sidekiq now. It's going to handle 1,000 of these. But now she's not doing it with 30 threads. So again, this guy's still kind of going along. Oh, 2 failed. I wonder why I failed. Oh, it failed because I exited, right? So kind of talking about this idea that if your server crashes, no problem, because it's going to go in this failed queue, and then you can kind of retry. You see this button here, retry, and remove. You can say, I don't want to do it again, but you can just retry. So that's that. And now here we have, look at that, 219, 192, and this guy, where's he at? 940, 939, right? And if you look at the busy queue, you'll see there's a lot more. Oh, it's done. It's done. Right? This guy's still kind of going. 929, 928, 920. Let's go ahead and kick it off again, just to kind of show him. Yeah. So he's still going. He's still over 900. And there you go, 872. And you see here how many jobs are running concurrently. They're all processing a different job. Right? In fact, I'm going to come in here and say, I don't want to just do emails, I want to do reports too. And reports they take longer, they take 5 seconds. And so now we should see, those are in queue too. And you'll see the in queue, you'll see there's 0 in the default queue, there's 414 in the emails queue, and there's 971 in the reports queue, right? And so this is kind of just churning, right? And again, because these are real simple, I could probably add 100 threads to this one process and get the scale of 1,000 times the work of a single process in Resque, right? Your only limitation beyond this point is going to be database, right? So this is another very tricky part about background processing threads. So if you move to Sidekiq, you can't just push it up to 500 or 1,000 threads if you're going to access the database. Because databases also have an upper limit to how many connections they'll accept. And so when you're kicking off all these threads, they're all going to have their own connection queue, right? And if you kick off too many, and your database only allows 200 connections, you're going to overwhelm it, and they're going to start failing and say, I can't get a connection because they're all taken up. So you have to, move these dials real carefully to get the optimal performance for what you're trying to do.